Hi guys, I'm Mike Sharma and I'm the Dean of School of AI Gwalior. I welcome all of you on the behalf of School of AI Gwalior team. This lecture is about some real basic data science stuff. We're going to be learning about some really cool data science tricks using libraries like Pandas and Numpy. So let's get started and see our agenda first. So in this lecture, we will be seeing what NumPy can do and what Pandas can do. And if we got a little time, we'll surely take a look at some Kaggle data science stuff. That's if we got time. So we'll be learning NumPy, then Pandas. Okay, first of all, let's install our dependencies. If you're using Anaconda, then you already have all the stuff that you're seeing on your screen. But if you're using a traditional Python interpreter, then you have to manually install all the required libraries. So for uh, for that, you need to open up the terminal or the command prompt and type in these commands so that you can install all the dependencies that we are required in this lecture. First, we're working on Jupyter Notebook. It is a really cool IDE, web IDE actually. You don't need to install any external softwares for that. It's just like a command, and then it will open up in your web browser. So Jupyter is quite great for us, and usually we use Jupyter Notebook only for data science and machine learning. Next up is the NumPy. Here we are using pip install, which means we are using pip Python package manager. So this makes our life easy. Yeah. Second one is NumPy, then Pandas, and SK image. We'll use later on, and last one is the matplotlib. So install these dependencies. If you don't have Jupyter Notebook already installed, make sure you have a good internet connection, and then run this command on your terminal so that Jupyter will appear. So to open the Jupyter Notebook, you need to get to the command prompt and type in Jupyter space notebook. This is what you need to do. Press enter, then it will start a local server so that you can get your Jupyter Notebook on your screen. So mine is already running, so I don't think I'm going to require this. So I'm just going to shut it down. Let me just open my Jupyter Notebook. Wait for it. Here's my Jupyter Notebook. Let's rename it by clicking over the untitled one. It's about NumPy. We'll be learning NumPy. That looks great. Okay, that already exists. So here is our environment on which we're going to be working on. Next up, let me introduce you to the NumPy. So NumPy is a core Python library in which, wait. So we're learning NumPy. If you want to do data science or machine learning, you're going to need to know the NumPy, numerical Python. It's one of the most useful libraries in Python, especially if you're crunching numbers. But why is it so good? Because it is fast and you can crunch numbers much faster than any traditional Python list or any Python loop. And it's also got so many built-in functions to work on, which makes our life quite easier. It also provides us a high-performance multi-dimensional array and some built-in functions so that we can work on numbers quite efficiently and quite fast. So let's get our hands dirty. Open up a Jupyter notebook. My notebook. Here it is. So if you've titled the Jupyter notebook, please tell me when to get started in the comments. I hope you are ready. If you have any questions regarding if you've got stuck in somewhere, please type in the comment section. I will definitely help you out. So first of all, let's import our library. This is something which will import our Numpy into our environment as NP. So this is basic Python syntax, so you don't need to get scared about it. If you know Python, then only you are here, I guess. I assume that you have the knowledge of Python. So as NP means we are giving it a nickname, or in language we say alias. So we are importing NumPy as NP. So everywhere wherever we want to use NumPy, we'll call it as NP. This is the traditional name. Everybody uses this. So as I've said, the NumPy gives us n-dimensional NumPy array, multi-dimensional actually, both the same thing. So there are many ways to create a NumPy array. So let's see the first way. I assume that you already know Python, so please, if you don't know Python, this lecture is not for you. So this is the first function that creates a NumPy array. So here you can see I've used the zeros. Zeros means each and every element is populated with 0. So you can see here I've written 2 as a parameter. So if you want to see how many parameters this function can get, please use Shift plus Tab key to see what this function can do. So this is the docstring of the function, how the function works, what are the parameters that it takes, and some examples too. So here I've written 2. So this is the shape of the function. So I've used a column. This is giving me a column vector. So it is a 2-dimensional column vector. Sorry, single-dimensional column vector is always 1-dimensional. I'm sorry about it. So if you want to type in, if you want to make a multi-dimensional shaped NumPy array, you gotta pass a tuple to get this multi-dimensional array. Okay, so this is quite easy. I guess you already understood what I'm talking about. So this is nothing, just pure basic stuff. So let's see what is the type of array. I've told you NumPy array is a type. So you can see NumPy.nd array, which means n-dimensional array, I guess. So this is giving us a NumPy array. That's quite great till now. You can pass in anything if you want in the parameter like 10. So you will get a 10-dimensional column vector. You can also make multi-dimensional, so it is easy. So now let's just move on to our next function, that is ones. Let's populate the NumPy array with ones. I know this looks quite basic stuff. You will get to know when you get to the end of this notebook. You will definitely learn something valuable today. So here you've seen that every element is populated with ones, which is a float. You understand what I'm saying? You feel me? This is a float. So let's see what's the type of first element, that is 1 point. So it's a float. It returns a NumPy float. Why? Well, they only know the reason, the creators. So it's always a float when you make when you populate a NumPy array. Okay, so let's see how can we create another other what's another way to create a numpy array. Before that, let me tell you an attribute for to, to check out the shape of the numpy array. Shape, number of rows, comma number of columns. This is what we call shape of a numpy array. So here I'm getting a tuple that shows 10 comma nothing. So it says that it has 10 rows. Okay, that's satisfying. Okay, so if you want to, there's a bonus tip for you guys for in the Jupyter notebook that you want to know what a particular function or what a particular thing or object does in a Python notebook. Just type in a question mark after that, so that you will get all the details that you need, or you can work on this quite easily. So here you got details about the numpy array, as I've put the question mark after that. So we were seeing types to create arrays. Next one is np.empty. So what it does, it fills out. Let's see what it does. It makes it fills out the numpy array with some garbage or random values which are useless. You can always replace these values, so it will return us the useful numpy array. You can always pass in a two-dimensional stuff like number of rows and number of columns using this shape thing. So here I got a 3x3 matrix type array. We call it matrix one. Next one is np.linspace. This is quite useful. Here you will here what these numbers represent is from a range of 0 to 100, please return me 10 numbers. These 10 numbers are not random. They are always the same every time you run the cell. If you and one more thing, to run the cell, either you use Control plus Enter or Shift plus Enter key. You don't have to go there and run it. It's just keyboard shortcuts. Thank me later. So here we got another function to create a numpy array. All right. I hope if you have any doubt, you're not hesitated to ask me in the comment section. I'm always ready to answer you guys. So don't be afraid to ask me questions. There's one more way. This is quite useful, converting a Python list into a NumPy array. This is quite useful. You're going to be using that quite many times in your data science life. Yeah, sure, for sure. That is np.array. What it does, it takes a list of numbers or actually numbers only. So Python list and converts it into a NumPy and dimensional. Let's see what's the type of this. If I'm going fast, please stop me. I'm just looking into your comment section and dimensional. Let's see what's the type of. Okay. So what I was speaking about is, yeah. So np.array is quite useful. You're going to use regularly whenever you want to convert a Python list into a NumPy and dimensional array. So here I'm taking another list, or let it be. Here's another list. Now, if you want to convert this into a NumPy array, you can just simply just pass the name of the list, and you will get a NumPy array. Here it is. This is another way to create a NumPy array. This is important, I must say. You're going to use it literally. You can also pass a two-dimensional array. You know what a two-dimensional array is? This is what a two-dimensional array looks like. It has various elements. You can always pass any dimensional array calls using numpy. So it returns the two-dimensional numpy array. Let's see what is the shape of this. This is another function. Find out the shape. Wait. Come on. Why am I using comma over there? So this returns the shape of the array, numpy array. There's few more functions. I hope I'm not going fast. If I am, just please stop me in the comment section. I'm again and again saying. Next one is some random stuff. By using this, we get random values in place of elements. We are populating the elements with some random stuff. So let's suppose I want between 1 to 10, I want 6 values. I'll be getting 6 random values every time. Every time I run the cell, I get some 6 random values. Are they random? Yeah, totally. So this provides us some random values. If you wanna need some random values for a particular number, you use random.seed. What random.seed does, it seeds the generator. Here, if you've learned Python, you must be knowing about the generators and decorators functions. So here, random.randInt is kind of generator. So it generates some random numbers for us. So here, if I'm leaving the seed parameter as none, default is none. So if I'm leaving this as none, I'm getting a random value. So if I populate this with some value, some integer, this will always give the same value every time I run the cell. For 0, it is this array. For 1, I'm sorry. For 1, it is this value, and for every other, for 4, it is this value. So it is not going to change every time I run the cell. So this is how we seed the generator with some particular number. So if you don't know what generator and decorators are, go ahead and learn Python again. Just kidding. These are some higher concepts, I guess. Higher function stuffs. Never mind. So we can also do slicing in Numpy. Slicing, everybody loves this. Slicing a string, slicing a list. Yeah, it's my favorite actually. Here I've got Z1, this array, and I want what? I want element from 6 to 8. Let's see how we're going to get this. No, man. How are we going to get this? So from first element to fifth element, what we got? We got the number from 6 to 8. So this is what we call slicing. This is the starting, this is the ending, and there's one more, I guess. We call it the steps. No. Yeah, this is what we call steps. Like how many jumps you were going to take in the array to get to the next element. So here I've written 2, which means I'm 6. After that, I will take 2 steps instead of 1. So I will skip 2 and then get to the 9. Then again, I will take 2 steps and 9 is excluded. So I'm not going to print it out there. So here it is the starting, which is included. Ending point is not included. And this is the number of steps. So this is how slicing is done. Let's do this using. So let's understand this topic using some pictures. So if you have any pictures, first of all, let's import this library that I've told you to install. Come on. Yeah, we got the library into our environment. Now let's create a picture pickware object which has this picture. You can use any picture. Make sure that it is in the same folder that contains this Jupyter notebook. So I hope you're doing this along with me. If there is any problem, please type in the comment section. I will definitely going to help. What this function does, it takes the picture and convert it into the Numpy array. Well, that sounds a little weird, but pictures are also numbers. So how you gonna believe me? You can see here, this is the picture. Wow, great. So this is the picture, but the object contains the numbers. What this function is doing, that it is collecting the numbers and converting it into the picture. So here you can see the picture. These are the number of pixels in the x-axis, and this is in the y-axis. So this is just numbers. This is actually picture is numbers. Let's see what is the shape of the picture. Actually, pic is a Numpy n-dimensional array. I know that's kind of surprising, but yes, it is. This is the truth. But in the picture shows the pixel sizes of the image. Actually, picture I'm calling the object, so don't get confused with this picture. With this picture, okay. So I was telling you about the slicing. So let's try the slicing a bit. You know what this thing does? Forgot to use I am sure. What this does, it takes all the rows and all the columns and print ourselves a picture. Now let's reverse this picture. How? You know it. Use -1 for that. Sorry, that didn't work out, but it does. No, it won't. It will surely work. Yeah, we just mirrored the image using Numpy slicing. Well, that's kind of cool. What is happening is we are taking all the rows and we are taking all the columns starting from the -1, which is the last element. So we are reversing only the column values, not the row values. So we got a mirrored image. Next up, we're going to slice so that we can get a part of the picture. I hope you're enjoying this tutorial. So we're taking the part of the picture. Wait. So what we're doing, we're taking out some part of the picture using the Numpy slicing. So you can see the size of the picture is quite large, since this is quite high quality picture. 2321 pixels by 3600 pixels and 3 colors. So I'm just taking out some pixels out of this. So what I'm doing is taking the 500 pixel to 1500 pixel from the row, and from the column I'm taking from 100 to 900. So I got a little part of this image. Here I took nearly this place and nearly this place. So I got this square as my output. This is just using the slicing. I'm not using any particular library for that. This is just Numpy. So this has been the slicing stuff. How to slice the Numpy array and all the things. I try to represent it visually because visual learnings are the best. Duh. Next up is how to use the mathematical functions in the NumPy. So I'm using sine function. Remember, this is in radian, so for 90-degree, I guess how much 90-degree equals in radian. Okay, I'll just copy it and paste it here. What is the value of sine 90? Let me remember it. I guess it's 1. So I got a number really close to 1. Really close to 1. So that's kind of insulting. Let's see if we can make it 1. Yeah, we surely make it 1. This is the real value of sine 90 degrees in radian. So we're using sine function to convert to get the value of the angle. Just like this, we also have a cos function. You got the tan function. You just name it. So if you want to see how many functions I'll be getting by creating a NumPy object, just what you have to do is type np and then dot, and then you press the tab key to see what I've been provided to work on. So these are all the functions provided in the NumPy library. You can use it. These are really awesome functions, quite faster than the basic traditional Python loops and list operations. Everything is fast when you use a library. So these are the functions. So let's see if I have a function for cosec. No, I don't have. What? No. So you can take out by using 1 by 10 or 1 by cos. These functions are provided, and let me put up some values in it. Let's find the values. 0 for all, not for all. We got the value for sine 0 is 0, cos 0 is 1, and 0 is 0. Definitely, these are the values. Apart from that, you can do basic Python operations, not Python, actually mathematical operations like addition, subtraction, multiplication, division using. So in NumPy, we do this for a NumPy array. So this pick is a NumPy array. So it is going to be summing up all the elements in the array and give us the total output. Well, what it will do is it will provide us the product of all element. Actually, it is element-wise product. And we can also do some statistics like finding the mean, finding the median, and standard deviation, variance. These are some built-in functions which are built on the NumPy. So every value, we have given the output of each and every function. This for the sum function, this is also important. For the sum function, see the doc string, you will get a NumPy array, and x is equals to none. X is here means whether we're going to be summing up row wise or the column wise. What kind of summation is this? Is it row wise or column wise? So for 0, it is column wise. For 1, it is row wise. For here, you can see if I, for the example, in this, let's copy this here. So here I've passed two lists. and I'm going to sum up these lists using numpy array. So x is equals to 0, which means it is adding up column wise. So 0 is 0 plus 0 and 1 plus 5. So I'm getting list column wise. So if I just put up a 1 over there, this will add up the row wise. Come on. What just happened? Sorry about it. I didn't see it. So this is row-wise addition. 0 plus 1 and 0 plus 5. This is what row-wise addition is. So x is equals to 1 gives us this. This is also quite a useful function. Apart from axis, there's also one keep divs. This is we're keeping up the dimensions of the array. Dimensions of the array, like whether we want to keep the dimensions up. If you've learned Python broadcasting, you will definitely gonna use this keep divs function. So it is either true or false, Boolean value it takes. Apart from that, there's one more function called argmin, which shows us, no, before that, there's a function called the maximum value, max value function. It will return the maximum value in the numpy array. So if we got the max function, we also definitely got the min function. So this will provide us the minimum value. So definitely, if we are using a picture, the maximum value of the color is 255. For the pixel, maximum value is 255, and the minimum one is 0. So I hope you got this. In the product function also, this is element-wise product. Apart from that, there's one more multiply. What it does, it takes proper doctrine. Okay, takes 2. So what it does, it does element-wise multiplication, like 1 times 2 and 2 times 3. So it will return us numpy n-dimensional array with 2 and 6 as an output. So this is what multiplied function does. Apart from that, there is also one more function argmax, which will return us the index of the element which is maximum in the n-dimensional array. At this index, we got this value, which is maximum. We also got a minimum value function. So at 0th index, you will find this 0 value. These are some other useful functions. Next up, let's do some logical operations on an n-dimensional numpy array. Let's create another numpy array using this, passing the list. We got this set. So how does logical operation works on numpy array? You use logical operators for that. So let's see how many values in this numpy array are greater than 5. So first value is not greater than 5, second one is not, third and fourth are greater than 5. So this is real good broadcasting provided to us by the NumPy library. This is quite easy. If you have to do this in C++ or Java, this is quite tricky to use. You must have to use the loops and all things. Often, let's see what a grade less than 5. Okay. First and second are. I again use the greater than, I guess. These are less than. First and second one are less than 5, and last one not. So there's one more thing, we call it masking. This is how it looks like. So the values which are less than 5 in Z will be sliced up from the Z. So 2 and 3 are less than 5 in Z. We can also override this, but I'm not going to do that. So I'm going to make a new variable, and we got a sliced up condition logical output. Yeah, this is what we call masking of results. So let's see something in the picture. There's one more function, we call it np.where, which means wherever there is a number in the n-dimensional array is greater than some value, if this condition is true, then convert this and then replace all the values on that place to 255. If not, if the condition is false, then replace it with this number. So this is how np.where works. If you don't understand this, please follow up the documentations, because you can get anything from that. So np.where provides us a conditional result. So what it is doing is, let's see in the output only. This is the output. What it is doing is, wherever the pixel value in the numpy array is greater than 50, so wherever it is true, it will replace it to mask it to 255, and wherever it is false, it will just replace it to 0. So we get output like this. So this is how the back end of image processing works. You can also use libraries like OpenCV to make things like this. You'll get to learn about. Apart from that, there's some more things that you're gonna understand about the NumPy. I think it is taking too long. Just to learn NumPy, we'll spend 40 minutes. That's a quite long time. I'm creating another NumPy array with some list. I hope you're doing hands-on with me, because you will learn quite better with that. So we got two NumPy arrays. We can also perform operation between these two. Just like addition, we can add up both the NumPy arrays. Sorry, I think the shape is, yeah, this must be a comma. So it has to be of the same shapes. Shape, if you want to check the shape, I've already told you the function for that. That is a array dot shape and b array dot shape. You have to be definite with the shape thing, because in real world also we can only add up the matrix with the same shape, because it is an element wise addition. You can also we can also add a scalar quantity to this, like 12, any value. So each element will be incremented by 12. Also, there's one more thing, product. You can also do product between two arrays. So this is element wise product. So 5 times 9 is 36. So it is like that. Also, you can multiply a scalar value to all the elements. So I multiply 124 to each and every element. So it is 124 times the previous one. It also changes, I guess. It does not changes the real array. Okay, so if you want this to get kept, either you override this thing by this, or you can create a new array for that. I hope you're getting my point. So in previous classes, you must have learned about something we call it a dot product, right? So in like previous class, like 11th standard, 12th standard, you must have learned about the vector dot product. So we can also we can also get the dot product out of the NumPy arrays. It is also called scalar product. So at the rate function does a dot product and it will return out the scalar value for us. Also, you can use numpy dot function. So these two things are same and pass in the parameters as both the arrays. So we will get the dot product. Both are same, but the syntax is different. One last thing is transpose of numpy vector. So again, I'm going to represent it using pictures. Picture. So what I'm doing is this here. This dot t will transpose all the all the columns and rows. Transpose means interchanging the row value to the column value and the column to the rows. So I'll be getting a transposed image. I hope this won't work. Yeah, it doesn't. Will it work? No. I have to do this. So I've got a transposed image, so the rows values are interchanged with the column values. There's also one more thing I forgot to tell you about is np.sort. So if you pass in any list of elements which is not sorted, it will return us the sorted element of list. So this is one of the functions. So this is all about NumPy. This is quite basic stuff and quite great basics. And if you want to dig deeper into that, I would always recommend to follow up the documentations, because documentations are the best. Okay, this has been the NumPy stuff. Now it's time to learn about the pandas. Yeah, you heard me right. Pandas. No, not this pandas. This panda. Panda is again an open source library for the Python programmers. So pandas is an absolutely essential. Wait. Yeah. Pandas is an absolutely essential Python library. If you want to become a data scientist or a data analyst, why? Because in those fields you will spend most of your time preparing the data. It's what almost every data scientist does. Like all, I don't know, 70, 80% of the time. You don't believe me? Go and read out the article by the Forbes. So now it's considered most of the boring part of the job. It's a bit, but that you have to do before you can do some exciting stuff. You have to clean up the data. You have to do some other stuff like removing out some garbage values. This is what cleaning is. So to do some exciting stuff, you have to do some hard work. So using pandas will make it quite easier to work on data, analyzing data, and working on data. So it depends on where you get data from. It might be quite dirty get data. I don't have to use this word. This must be some other word for that. Unclean data, yeah. So pandas will help us to clean the data and to organize the data into some form that machine can easily do some work on that. So main purpose of pandas is to prepare the data for the future tasks. Okay, by learning pandas, you will be able to automate the process of preparing the data in and which is quite essential. So we're going to learn how to do it. Pandas provide us two really cool data structures. I'll talk about them in a moment. First of all, let's let's just create a new notebook. Just click on new and then Python. Uh, yeah. So let's create a new notebook. So using pandas is a little bit great when you provide with stuff like series and data frames. So first of all, let's import the pandas. Just like Numpy is imported as NP, pandas is usually imported as PD. Pandas is quite demanding, quite interesting to learn, and quite demanding in today's market. I wish I could show this image. Yeah, surely I can. Yeah, what this image it does. Sorry, hold on. This is the data representing the how useful the pandas is in today's market from 2009 to 2017. It is increased in usage and in applications. So sorry, guys. This is pandas. Just like NumPy provides us a basic array data type and some operations which we can perform on that array, pandas also provides us really cool 3 data structures, out of which we're going to be studying about 2. First is series, second is data frame, and third one is panel. So panel is out of the league right now, so I'm just going to teach you series and data frames. So with pandas we can do with what pandas provides us is defined fundamental structures for working with data. Apart from that, some really cool methods that facilitates operations such as reading in data, adjusting the indices, working with dates and time series, sorting and grouping the data. Also reordering. You will get to know about what I'm talking about. Also, and at last, dealing with um, dealing with the missing values. So this is the functionality that Pandas provides us. Uh, we are provided with functions to read the data, adjusting the indexes for the singular, working with dates and time series, sorting, grouping, and reordering the data, and at last dealing with values. And there are a lot more functions than these. So we're going to take a look at these. First of all, let's import the pandas and NumPy because we are going to use NumPy too. So we're provided with something called as a series data structure. Okay, so you can think of a series as a column of data, such as collection of observations on a single variable. For example, you're collecting just the heights of the persons in your class, so you'll get a single dimensional list with the indexes. So this is what a series data structure is, or data type is. So how can we create a series data type? PD dot series. We're instantiating an object of series. So let's see the type of this object. It is a Pandas series object. Wow, we just created a Pandas series object. Isn't it great? I don't think so. So let's fill up this series with some NumPy, with the help of NumPy using some random values. And let's just name it something. Blah, blah. This is what I'm doing right now. So let's see how does a series looks like. We got 4 random values with indexes starting from 0. We got the name of this, and data type is float for each value. So this is the random value we're getting from the Numpy random function. Also, we can also do one more thing. We can also create a series out of a Numpy array. This is what we have done over there, and also we can do this. Sorry, I haven't written the code. I'm just doing it in my mind, even. So I have to think a little bit about it. So this is also Numpy array. In data variable or object, we call it. So again, we created a new series object and pass it data as a parameter. So we got this as a series. You feel me, right? You have to feel me for that. So this is how we convert a Numpy array into a series object. So okay, you can also create a series from a dictionary. I forgot to use this in the last video. Come on. I guess I spelled it right. So again, let's create a dictionary. If you know Python, you already know what a dictionary is. A key value pair. See. Okay, we got our dictionary, and let's create a series object. We will get to know what are the application of these things when you work on real data. I will tell you how to do that. So we got a dictionary. What dictionary does is it does not have built-in indexes. We are giving up the indexes like A, B, and C. So this is also a series object. If you don't believe me, just check out the type of this. This is also series object. I don't like it. So as an index, we got the key values from the dictionary. As the real column value, we got the value pair of this. You can also make a customized what do you call it, series object using lists. Yeah, right, you heard me right, list. This is going to be a bit longer, I guess. Let's create a list, 4 elements, and there's also a parameter called index, so which will provide us the application to work, change the index or make a user-friendly index. What the hell just happened? Sorry, I forgot to give the last index. So again, we got a series out of a list. All right. We can also always multiply each and every object, just like we did in Pandas. So every object is multiplied by 100. Every element, I guess. Sorry, not the object. There's one more very important function called describe. What it does, it returns out all the important information out of the object which we require, like statistical data. Did I spelled it wrong? Yeah, sure. So we got the count, the number of elements in the series object, some statistics like mean, standard deviation, minimum, and maximum value. So this is all describe does. So this is quite important function. There's also a head for series. Yes, there is. What it does, if we have got, this is just 4 element series. If you have the series quite longer than this, like thousands of elements, this will give us the first 5 elements if you do not provide any parameter, or if we provide the parameter, it is going to return us the first n number of elements. Okay, just like heads, we also got tails. So this is providing us the last few elements. So what's in the S? Let's see. So let's just change the indexes of X using the S dot index attribute. Let's just give up stock tickers. This is the stock tickers of big leagues, big companies. I must you, as you have already figured out what I'm talking about. So I've changed the index of the list of the series object. So this is stock market tickers. That's what we call them. So it is quite fast than dictionaries or any other data types. That's why we are using it. Of course. Apart from this, you can also always access any element from their indexes. So for like just like in Numpy, just like in any traditional Python list, you can access any object like this from the index value. So I'm also using index column. Also, you can change up the value at any place using this. Here you can see I've changed the value of the fourth index. Next up is a data frame. This is all about series. While series is a single column of data, data frame is several columns. Data frame has several columns, one of for each variables. It is quite analogous to the Excel spreadsheet, but highly optimized because we have provided it a lot more awesome functions. So this is quite great. This is great. We are on the data frame thing. Who's the one watching this tutorial? Who's watching this? Oh, got two audience. I should not be looking at the viewers right now because it will be recorded and we'll be getting more viewers. So we were talking about the data frames. So just like in series, there's a single column. In data frame, we are provided with several columns, one for each variable. So as I've told, it is just like this Excel spreadsheet, but highly optimized. So, so how do we create a data frame object? This is how we call a data frame object, not called, create a data frame object. Usually we use df to represent the data frame object. So you can always, this is an empty data frame object. So we're just gonna use, we're gonna take out, we're gonna read the data from a CSV file or comma separated values file. Either we'll take a local file or I'm gonna just take out from the GitHub. So this is what a data frame looks like. This is a data frame in which we got a country and country's ISO code. This is data about something important like this. So let's work on this data. We can always do slicing of data just like we did in Numpy. So I want 5 columns from 2 to index 6. So X6 is included. So it will return me out this thing. Next up, you can always call out from index. This is a quite great functionality that we were provided with. So there was a country column. I forgot to write this. Sorry. COUNTRI. What's that? Yeah, this is the code. So we are using index as a column name. This is called column name or the features if you do machine learning here. But here in the data science, these are called the column names. This is what we call index of the column, index of the uh, data frame. So this is how we are taking out the data using column forms. There are two really important attributes in provided by pandas to us. There is one is iloc and second one is loc, iloc. What these two column does it, I'll first of all let's see the iloc. It will return us the column. It will return the new data frame in a sliced manner as trimmed as possible. Like I want second from second to fourth row and zero to fourth column. So I will get this. So it is just trimming up the data set using number index. Okay, if you want column, if you want to trim it with column values, you will use df.loc. Okay, so what I'm going to do is first of all I will trim from rows using this function, and if I want to trim it from column, I'm going to use the column names. So I only want these columns. Sorry about it. These to count TCGDP. So I got a trimmed data frame. Okay, so you can always make a new variable out of it, all those stuff. Apart from that, you can always reset the index using df.set index function. How? I'm going to make the index out of the country. So now country is an index. There are no numbers left. So from country, I can access all the stuff. Like if I call out for Argentina, I will get this whole row data. This is now country is my new index. Okay. Next up, you can always rename the column names, or we can add up new columns using what column function, column attribute. Oh my god. Actually, it is for replacing the column name, so I'm going to replace to the GDP from population to total GDP. Come on, work out, dude. Why isn't it working? Again, sorry about it. I have to make, I have to set the index to this, and yeah, now I guess. So let's again rename the column. Do you have thought what's the name of this is? So you can directly access the column name and replace it with what I just did is replace all the values. What an idiot. I replaced all the values in this column to 12. Oh, I was supposed to do something else. Actually, this is how it is done. No, uh, let it be. I forgot how to do this. Sorry about it. I'll definitely get back to you regarding this. You can always do one more thing. You can multiply with a particular number to, to any column of the data frame. Like I'm going to multiply with 12. What I'll be getting is multiplied with 12, each value in this column. Apart from that, you can always perform any mathematical operation in this pandas. So let's create a sample data to learn another thing in data frames, that is re-indexing. I know it sounds quite not a good thing. So let's create a data frame, a new data frame. This is the index value, and this is the value that is the column value from using built-in functions provided us by the pandas. What I'm doing right now is making a data frame which has a column which contains the dates starting from this date and with the period of n, which is 20. Next up, we are provided with x, then we are provided with y, and last, I hope you're coding with me. Let's use what we can use. Let's use Numpy linspace. I hope you remember what it does. It takes a value from one interval in between an interval and take out, return us the number of elements we want. Again, we use random module. What am I doing? We will return 20 random values. Again, we're gonna use random. But I forgot to tell you about this function. What it does, it generates a random sample from given one array. That's a lot of information. We are near to the end. So I'm using some built-in functions to fill up this, to make a numpy. Numpy. It's a data frame object. Great. State range, and it didn't work out yet. Yes. So we just created after a lot of hard work, we just created this data. This is a fake data set We just created it up using this piece of code. What we're doing is, first of all, in column A, we got the date, 20 dates, starting from this and ending one, incrementing day by day. And second up, in the X column, we got to use the numpy's linspace, which you already learned what it does, and use some numpy random function. So this is what we did to create a new data to work on. So let's see, let's use the function that we have already learned. So we got the description of this data frame. There's also one more function called info. It tells us how many null or non-null values are there in the data frame, all the things about it, the types of data. So you can see first is datetime object. We will get to know what that is. So we were reindexing this. So let's create another object. Df. So there's a function called reindex to reindex the data frame. What I'm doing is using the reindex and changing the indexes of 0, 2, and 5 column of A, C. Let's see what we got. We got stripped out a new column B with some empty non-values. This is not a number. This means here we got a new data frame using the reindex. So with the index of 0, 2, and 5. So we got this value, and this value. All right. This is how reindex works. Now I think it's time to work on some missing data. What and when and why data is missed. Suppose you're doing any project of IoT and continuously each and every second the data is coming to your spreadsheet, and due to some technical fault, some connection lost, the data might get missed coming from the source to your spreadsheet. So this is how data is missed. This is one of the example. Next up, we're working on missing data. So I've already created a numpy, a data frame using numpy's random function with columns 1, 2, and 3. Let's see what's in this data. Please see this data set. There's nothing missed in data. Let's use the reindex function to miss the data and to make some columns missed. Yeah, what we've done is we created some new indexes which don't have any values in them. So we reindexed a whole thing with these indexes. Before that, we got these indexes. So now we got a miss, not so clean data. So there's a function in Pandas which will check if there is a missing value or not in a particular column. So this function is called is null. If there is any missing values in this column, we call 1. So it will return us the true, and if not, then it's a false. There's also a contradictory function from this one. We call it not null. So let's see, not null. So this is just the opposite of this. So if there's no value null, then it will return true. So first of all, there are so many ways to fill up the missing values. You will learn it when you learn some statistics. like filling up with mean mode or median or the maximum or minimum or the one adjacent values. So there are a lot of many ways you can learn it in the documentations. So next up is the calculation of with missing values. So first of all, let's use functions like dot sum. What it does, it will sum up all the numerical values in this column and return us out with this with the output. Okay, so we can either fill up the sum of all values, which is quite injustice to the data. We usually use median values because they are most most useful, no, most efficient. So there are quite less chances of getting an outlier or anomalous value. We will get to learn about outliers in next sessions of SOAI team. Just bear with us. So if the data are all non-values, the result would be we got some data frames. We were working to fill up the null value. So here we can see there's a sum. So let's take it in a variable, and there's also a function called fill NA provided to provided to us by Pandas. What does it will fill up the null values with the sum of whatever we pass in this. So we can also apply any function in this using lambdas or apply methods. This is how this is this is how to fill up the null values. Either you use sum. Fill NA is quite useful when you work with real world data. There's also one more thing. So here you can see there's null values. So there's one more function to work on is drop NA. So what it does, it will just discard all the null values from a particular column. Drop NA actually. So we got all the filtered data frame which does not have any null values, or you can do this for the data frame too. You can also drop values from the column. There's always an access attribute. Oh. This is fine. So I guess I think it's time to wrap up because we stretch a lot of ahead and we got quite limited time. So I will surely do Kaggle if we got some time, but in the next session we surely do Kaggle, and I will definitely make you work on data on some real world data sets. Like we'll be starting with iris data set, and we'll be submitting a Kaggle competition in the next tutorial for sure. So this is all about some basics about the pandas and numpy. If you want to learn quite a little deeper, because these are the only things that we'll be using if you do data science and machine learning. Apart from that, if you want to get in some, if you want to literally waste your time, just go and learn a little bit more about it. I should have said that. Never mind. This is the basics, and if you want to learn a lot about it, there's always documentation. So just type in the library name and then documentation and open up the first link. You will find the best resources in the world. Whatever you want to study about, you will get on the documentations. If you want to study some real deep in text, you will find it over here. Like I've told you about panel in the starting, that this is also a data frame. So oh my God, it is removed from the, I'm sorry about it. That was a blooper. So you want to learn about data frames. These are all the functions that data frames provide to us. Like we have learned about what? index. So what it does, it just returns the table of index log. We have learned about it. So this is all the stuff about the log. There's some code that you can apply in your notebook. So if you want this notebook, I will definitely upload it on to the GitHub or any other platform, any other shareable platform, or we can just post it on the web. This is all about us. If you want to give us feedback, this is the site where you can go and fill up the feedback form. This is really valuable for us to improve for the next time. So at last, if you want to learn a little bit deeper into these things, you can definitely go and check out the documentations and other tutorials on YouTube or any other coursework website. So because of lack of time, I have to wrap up this thing over here only. But we'll definitely catch up in the next lectures. So this is for today, guys. And bear with us. Thank you very much for your support. That's all. Good evening, good night, bye bye.